This message is brought to you by DoNotAge.org, the longevity research organisation that's on a mission to extend health span for as many people as possible via products that actually work. Start your journey today at DoNotAge.org and use code LLAMA for a 10% discount. That's LLAMA.
People don't want to die. The key to not dying is life extension through precision medicine, because only then you know what you're doing. And people are willing to pay for it if you show that you can actually move the needle.
Hello again and welcome to LLAMA, the Live Long and Master Aging podcast. My name is Peter Bowes. This is where we explore the science and stories behind human longevity. Now, changing the paradigm of healthcare is something I think we have to master so we can share the benefits of longevity research to as large a number of people as possible, populations as opposed to individuals. So what do I mean by that? Well, as many guests on this podcast have pointed out, most healthcare systems around the world are focused on the treatment of diseases as opposed to the detection of potentially life-threatening conditions before symptoms occur. That's a generalisation, but I think it's fair to say that we live in a disease care world. Well, my guest today is Joe Bhakdi. Joe is the founder of QuantGene, a Los Angeles-based startup which has a mission to build a future where everyone is protected against most diseases through early detection. It is a lofty goal, but it could happen. Joe, welcome to the Live Long and Master Aging podcast.
Hi, Peter. It's great to be here.
Yeah, good to talk to you. What is QuantGene?
QuantGene is a precision medicine company here in Santa Monica. We also have an office in Berlin, Germany, and some clinical sites in Europe and the US. And what we are working on is to combine deep genomics, cloud, and artificial intelligence into a new technology stack that helps us detect dangerous diseases like cancer and beyond that other chronic conditions so early that we can actually intervene and do something about it.
And the emphasis there, the first thing you said, the emphasis is on individualization in terms of detection. It isn't a mass style of detection. I think we all know that we're all individual human beings with quirks, and we respond to lifestyle interventions and to food and exercise in very different ways. And that's what you're focusing on, the precision nature of what you do.
Exactly. And that's why I emphasize the technology stack, the combination of technologies we use, but they enable us exactly to do that. If you combine genomics, cloud systems, which is, the internet and software, and artificial intelligence, at the center of that stands, cloud and AI are tools, but genomics is the data source. And what that does in medicine, to switch medicine from an analog science where someone just listens to your heartbeat or looks you in the eyes or something, to something where you get genomic data points from your DNA is a enormous game changer. To just tell you one example, when we do a blood sample for our early cancer detection system, we are getting 10 billion digital data points out of this blood sample. So we literally get a file with 10 billion data points, a FASTQ file, and then we digest and process that with a very large computing infrastructure. And these data points are pieces of your genome where we identify variants and mutations on all kinds of genomic fragments in your blood that might stem from a tumor cell. And that level of precision is literally millions of times higher than what's happening currently in conventional medicine. And this level of precision and this amount of data in the end translates exactly in what you say, personalized medicine. Because as you can imagine, if I get 10 billion individual genomic data points from a blood sample, you will never, ever have a blood sample that looks the same. And, each blood sample gives us a fingerprint, something vastly more deep and complex than a fingerprint about you, that allows us to see things that were just completely out of visibility of a conventional doctor. And that's the centerpiece to massively increase precision. And with precision comes early detection to see tumors, other conditions so early that they are not life-threatening and can be removed or can be fought.
Which is absolutely the point of this, isn't it? To detect those potentially killer diseases before we even know that we have them or even have the potential to have them. And I want to dive into that a little bit further with you. But first of all, just tell me a little bit about yourself and your own background, your own education. What brought you to this point?
Yeah, I always joke. I got my medical education in my first 19 years from 0 to 19, pre-college. I grew up in a family with two very passionate, bioscientists and doctors as parents, and, got always my dinner table education from my dad and also my mom. My dad is still active as a researcher, professor for microbiology. Yeah, I learned a lot as a kid on membranes and, toxins and proteins and what's going on in a cell and bacteria and all these things. And I always found it fascinating, but when it came to going to med school, I found it too boring. I felt like I have heard enough of that for 19 years. I want to learn. There must be more than that in the world. So I actually studied economics because I always wondered who's paying for all of that stuff. I don't know. It came natural to me, the question, like, how does this work from a resource perspective? Then went into business, and, after a lot of things I did in corporate and investing, and in technology investing, it all came back when, a family member asked me for help with a genomics problem. I'm basically a numbers person, right? I did a lot of financial stuff. I always liked numbers and complex patterns, and I always liked the more diffuse and difficult things. So probabilistic models and things like that, which are very useful in genomics. And then they approached me to ask for help with a sequencing problem, which was a math problem ultimately. And after solving that, it struck me as, carrying a lot of potential in cancer detection. It's, basically the question was, if you have a DNA in front of you, how would you tell that it stems from a tumor cell, or it is a tumor cell versus not? That's a very complicated question. You have 3.3 billion nucleotides in a DNA. Some might be mutated, but at what point would you call it a tumor, and at what point would you not call it a tumor, just based on the nucleotides that you see? It was a question where I thought we had much better answers, and I did a lot of research around it back in 2014, and so there is just no answer. No one did that before to answer that specific question. And so after we had the solution, it struck me as crazy that we could generate that solution, and that solution wasn't there before, because that is the centerpiece of a new company, Quantgene. Because with that, you can detect cancer early stage. If you can tell people based on a DNA strand and on the mutational patterns on that DNA strand if it's cancer or not, you made an enormous step forward, because from there you can do that with blood samples, and it allows you to become, to generate a single molecule precision approach, where a single molecule of DNA would allow you to already say if you have a tumor or not in your body, which is vastly more, high resolution than a mammogram or something like that.
So the company, you mentioned the timeline there, the company started in 2015. It's now 2021. You're still a relatively young company, but in that time, you've made a significant amount of progress. And I'm just curious about the business environment surrounding the launch of a company like this. Is there a lot of support?
Yes, fortunately, there is tremendous support. When you talk about extending the healthy human lifespan by 10 years within the next 10 years, which is our mission, my mission, but also Quantgene's mission, you get a lot of support. It's creating a lot of goodwill, and I'm super grateful for that, because there is always a leap of faith in the beginning, right? No one can guarantee it works out. So we got a lot of support, raised roughly 22 million so far, and made tremendous progress. So it sounds like a lot of money, but in our space, it's actually not too much money. So we were very lean in building our sequencing labs, doing the R&D, building the cloud and AI systems, setting up clinical trials, one of the largest trials in the world now in cell-free DNA cancer detection. And now we are taking it to the next level, much more institutional on the capital partner side. That is a whole new ball game. But I think we have I have some experience in that, so I think we find good paths here. The challenge is always that if you do something very new, which we do, you don't fall into any conventional pattern or bucket. If you go to a biotechnology fund, normally they don't understand really what we are doing because they think very narrowly, okay, you're a diagnostics company, you need to get Medicare reimbursement, and then you sell this little diagnostics piece to a lot of doctors. And if you don't do that, we don't know what you are. And of course, we have a much more complex, much more holistic business approach where we build a medical group, where we work with medical groups and build clinical delivery systems. So it's a healthcare play as much as it is a biotech problem, because it's all about how can we get it in front of patients and how can we get patients access to that. And in the first step, that's not insurance driven, because the insurance is a whole different problem, right? When they would start paying for preventative care, they just hate it because it's against their business model. So, we have to innovate the business model. We have to innovate the medical delivery system, because if the doctors don't know what this is, you cannot get it to patients. And we have to solve the biotechnology problem, which is heavily cloud and AI centric, which most biotech problems used not to be. So you're crossing all these different things. You're doing a consumer product, business model innovation. You're doing a lot of medical innovation, medical processes. And you're creating a new form of biotechnology that is much more data-driven and artificial intelligence-driven than conventional. And then you merge it all three together into the real business. And then we created probably the most exciting company, in my opinion, in the world right now, with its upside and everything we can do. And that creates a lot of momentum and attention we get. But when it comes down to the details, a lot of investors don't know what to make out of this new animal, because venture investors, also innovation investors, still have a hard time to being really innovative. They like patterns that they have seen in the past. And of course, real innovations never fit the pattern. So, because they're new. So it's an interesting suspense where we definitely get a lot of attention and support. But when it comes down, it's still not easy to take it to the next level. But I think looking good, but it's not the easiest.
And we'll continue this conversation in just a moment.
Hey, quick question for you. Are you someone who wants to be fit, healthy, and happy? And what if I told you could get your dream body by simply just listening to a podcast? I'm Josh.
And I'm KG, and we're the hosts of the Fit, Healthy, and Happy podcast.
Listen, we get it. Fitness isn't easy. Carbs, no carbs.
Just stop, okay? It doesn't have to be that complicated. And that's why we made this podcast. We get straight to the facts so you can become your best you.
So the way to check us out is click the link in the show notes or search Fit, Healthy, and Happy podcast on any of the major podcast platforms. We'll see you soon.
Well, I think it's fascinating, and you mentioned perhaps the lack of understanding in the conventional medical world with doctors, perhaps resistance from the insurance company, and again, a lack of understanding perhaps from investors. But these are issues that you have to surmount, because ultimately you've got to deal with patients, and patients are all very deeply involved in at least the conventional medical world and the insurance world, especially as it applies to the system here in the United States. So you've got to kind of close that gap, haven't you?
Yes, and it's a very strategic and philosophical question. How do you build this company? How do you keep your eyes on the target, which is a very big target? How can we extend the healthy human lifespan by 10 years within the next 10 years? What is the technology and medical stack we need to achieve that? And how can we make it happen? And for me, I am a deep believer in first principles. They allow you to keep the eyes on the target and not get distracted by noise. And my first principle, where we align the company to, is very simple. People don't want to die. The key to not dying is life extension through precision medicine, because only then you know what you're doing. And people are willing to pay for it. And if you show that you can actually move the needle. And if you have something that every human basically wants, and every human is willing to pay for it, you don't need the insurance anymore if you can bring prices down reasonably. And if you have a business, even if investors don't really understand the pattern and it's too complex for them to understand, what they do understand is, okay, look, we have 5,000 people on the wait list and each of them wants to buy it. And our only problem is we have to streamline the processes, and we already have 100 through. And, soon we will have 1,000 through, and then we have very streamlined processes. Because then you can actually bring it back down to business as a general principle from an investment point of view and say, even if you don't fully understand all the details or that don't match your patterns, we have overwhelming demand, it's profitable, and we can scale it to 1 billion people. So that's pretty good. And I think that serves us pretty well to have this big picture. And I think people, start to really get it.
So let's just delve into what it involves in terms of the use of what you have developed, the technology. Now, I like the analogy of a fingerprint essentially being the end product, or at least the detection stage of what you do, very individualized to a person. Can you explain to me from a patient perspective, interacting with what you do, what does it involve for the individual?
Well, if you decide you want to do that, we have, it's right now, we're trying to get to a monthly pricing here. So it's going to be $225 a month or something roughly. It's an annual checkup that you do, and that goes on for some time. So the way you do it is you sign up, and then you get a first intake form where you start entering medical information about yourself. That is very important for the data system. Then you will have a counseling session with a genetic counselor and a medical expert to explain how it works and what it is, and also informed consent that you understand, okay, if you do genomics on you, there might be findings that you don't like and that create anxiety. So are you okay with that, or do you not want to know certain things? So there's a certain, informed consent, very important. Then you will get a kit where we collect saliva sample for doing whole exome sequencing. So part of the service is also, which is very valuable, to look at all your 20,000 healthy or regular genes and all variants we found on germline, so on your hereditary side. And then on top of that, you will get a blood draw where a nurse comes to your home, draws 3 tubes of blood. Sounds a lot, but it's not a big difference to one. Takes 20 seconds longer. And then we have 2 laboratory processes. One where your saliva is being processed for your whole exome, for your germline genes. We look through 30 million locations on 20,000 genes, basically your entire genome that is coding. And in parallel, we do what's called a liquid biopsy, which is our, what we took a long time to develop, where we generate these 10 billion data points out of your blood. And once we have these results, they go into the Serenity engine, which is our cloud system and AI system, where there's a lot of data crunching going on. So we run your sample against very extensive cohorts of clinical trial samples that we generated. So we can basically take now your mutational pattern that we find in the blood with single molecule precision. So we know it at that specific location. We found 2,500 copies of DNA in your blood, cell-free outside cells that stem from cells that have died, including potential tumor cells. And out of these 2,500 copies, let's say 3 carry a variant that is associated with cancer. That's not a bad thing necessarily, but that's good to know. And then we collect that over thousands and thousands of locations, these exact variant allele frequencies that are called, like is 0.1% is, something. And then we run this entire pattern against these cohorts and see what type of pattern do you have? Does that look most like early stage pancreatic cancer, for example? Or does it most look like normal people? Or does it most look like pancreatitis? Right? Also, not just cancer. Does it look like an inflammatory condition? Or what is it? And that's a probabilistic thing. It's very complex, right? So there's no clear answer. It doesn't say, oh, you have that cancer or you don't. It says, well, after running all these things, here's how it looks like. And then on our side, there are trained physicians, genomic specialists, medical specialists who start looking at that. It's like, well, Peter's pattern, there are 2 orange flags, no red flag, but 2 orange flags that are a little concerning. And then they take into consideration the other 2 data dimensions, which is your whole exome. What is your hereditary, condition and risk predispositions, and the medical intake. Are you a cancer survivor? Did you have cancer in the past? Are you currently diagnosed with cancer? Then it's a whole different thing. Then we look for different questions. Or are you at high risk, right? Are you a heavy smoker, obese, and all kinds of family history? And then we overlay all these things and we look at your current patterns, but we also understand your risk predisposition genetically, and we understand your risk profile medically, just on your record side. And then if you put this all together and have a lot of statistical models that are hopefully smart, you get to your orange flags or red flags or green flags. And they're being interpreted by trained physicians. And they say, Peter, here's the situation. We think right now, there is no reason to go into any downstream diagnostics, right? So we do not recommend a colonoscopy outside your normal colonoscopies. We don't recommend abdominal ultrasounds or CT scans because based on these results, we don't think there's a reason to do that. But we see 2 orange flags. What about putting you a little bit on a more strict nutritional regime to see if we can actually bring these down? Because we saw on your medical intake that you eat 2 steaks a day and drink, 2 whiskeys. So that and the orange flags we see could implicate that you have colon, mutational issues. I'm just making this up right now as a case. So they could say, why don't we cut down a little bit on your stuff, increase a little fiber, get a little bit more rid of the alcohol, and do a test again in 6 months and see if we see any changes. So I told you basically more a complex case. Normally, most cases just are green and they say, well, it's looking pretty good. Or red. It's like, well, we should do an abdominal ultrasound here to see what's going on. But it becomes a very high resolution game. That's exactly what we want. We want high resolution, highly personalized precision medicine based on billions of data points across 3 very orthogonal dimensions to see, what's going on, to give you a much, much more rewarding medical feedback than your conventional primary care doc saying like, oh, Peter, what's your problem? It's like, I don't know. I don't have a problem. I just want to know if I have a problem. And it's like, I don't know what to do with you. Go home. So that's the idea, to provide patients with a much deeper insight of what's actually going on.
So crucial to the analysis of the data that you are managed to, this picture of someone, this fingerprint that you're managing to build, crucial to the analysis of that is external information. It is the knowledge of the lifestyle of the person, as you said, whether they're eating 2 steaks a day, whether they perhaps spend too much time in the sunshine or too little time in the sunshine. That's crucial to giving the patient something meaningful for them to go away with.
Absolutely. And that is another thing here that is very important to understand. So glad that you brought it up, Peter. That's because most people are not fully aware how medicine and diagnostics actually work. So if you do a conventional test, a PSA test, someone came up with a number and says, oh, well, if it's 7, it's bad. If it's 3, it's not great, but you're below a threshold. That is the old way of doing medicine. That is highly problematic in a precision medicine world because it is not reflective of your true personalized risk. And in order to make sense of any result, you need context. So the human brain does that, right? So if you, for example, say, if you're scared of terrorists and you try to spot terrorists and, okay, what is a pattern of a terrorist? Well, behaves like a little awkward, looks away and tries to not be seen, but looks like very aggressive and makes some aggressive moves. Okay, fine. We get this pattern, right? If you just have that pattern and just look for that pattern and you see that pattern and have no contextual information, next thing you know, you arrest like a 2-year-old baby girl because she did that. But the context would say, no, stop, the pattern is true, but only for like young men or something between 18 and 25. And say, oh, fine, that was important to know. No, don't arrest little baby girls. They're unlikely to be terrorists. So our brain does this automatically. It's never just one pattern. It's always an overlay of many patterns. And what that means is if we get a liquid biopsy sample back, the question if that's a red flag or an orange flag or maybe green, it's not just the liquid biopsy pattern that we get from the blood. You need to overlay your other risk profiles. And for the statisticians or math people who are listening, in the end, it's a question of positive predictive value. The question is, if I do something with you, you want to know only one thing in the end. What are the odds that I have a problem? Is it 1% or is it 90%? And in order to determine these odds, it's kind of a Bayesian problem. It's not just one test. It's the test, and then the probability, if that test is positive, that you have a problem, not someone else. And an important question to determine that PPV, this positive predictive value, is before you do the test, what is the underlying risk that you have? Because if that risk is very high and the test comes back positive, the probability that you have something is much higher than if your risk is tremendously low and the test comes back positive. It's like pregnancy tests. If you do a pregnancy test with 5-year-olds, 5-year-old boys, a bunch of them eventually come back positive. It's just a question of diagnostics, right? The odds that the 5-year-old boy is pregnant are just 0. So it doesn't matter if it's positive or not, it will be 0. But, if it's a 22-year-old girl, it's just higher. That's what people sometimes overlook, and a pregnancy test is a great example. I mean, what are the odds you're pregnant if you have a positive pregnancy test? I tell you, it is important who took that test. 80-year-old guys, it's very unlikely they're pregnant. But it's definitely possible that the pregnancy test is positive. So that is why it's so important to overlay these things and do it statistically sound and know, okay, if you have a BRCA mutation germline, so if your normal genome has a BRCA variant, so your odds of getting GYN cancers as a woman is very, very high, 80, 90% in your life, then, when something comes back flagged in liquid biopsy, it has a very different meaning from someone who's at a very low risk. And same is true for your lifestyle and so on. So normally, in normal diagnostics in biotech, the biotech people don't deal with these problems. They say, we don't deal with that. We give you a tool. You are the physician. You have to figure that out. The problem in this new world of extreme precision medicine is if you're a conventional physician, you're not trained in artificial intelligence and cloud systems and genomics, you have no chance getting that right. I mean, what are you going to do? Read through 10 billion data points and then think about what it means? It's just not happening. And so that is the gap. That is what's holding precision medicine back the most. That there is no company that integrates these different questions and makes sure in the end, the patient needs to know if there's a problem or not. And if you don't get there, it's useless.
And that brings me on to exactly the point that was going through my mind as you were just saying that. Let's say there's a red flag, an orange flag for pancreatic cancer. That clearly is very significant for the patient. And as we all know, pancreatic cancer is an extremely serious condition and needs to be looked into further. That patient is dealing with a doctor in the conventional medicine system, to use a phrase, and it's a concern of mine that framework that they're working in already isn't geared up to fully understand what you and what your diagnostics are telling them.
Exactly, and that is why we designed the whole system as something that goes far beyond the diagnostic. It goes into what we call Serenity, the future of medicine, where you overlay our conventional care system with a much more sophisticated, much more advanced system of medicine that we also design. So we don't replace the conventional system. You're still going through the conventional system, but there is a layer above that you get as a client where we steer and oversee what's happening. We can't control it directly. We can't force people to do stuff, but we can get them information and get the patient information. We can say, well, maybe your primary care doc now is very confused because they don't know what to do next because there is no early detection for pancreatic cancer. Therefore, there is no good known downstream diagnostics path, right? If you say, oh, it might be pancreatic cancer, then most people don't even know what to do. Okay, what do I do? An ultrasound, endoscopy? I don't know. Can I just send you there? Should we do a protein test? Many people are not totally clear what to do because that whole system doesn't exist. So then at that point, if you're a customer of Serenity, we guide you through that process and we guide your physicians. So that is very important. And we are also, already working on more downstream products because if you actually then get diagnosed with cancer, that's a turning point. Also for Serenity, right? We cannot provide for the same price like a full-on oncology advisory because it's just, we need to be really on top. You need to then go a little out of your way to make sure this works. But we always develop technology and clinical in parallel because we don't want to throw technologies out and then no one knows what to do with them. You need advisory. You need medical advisory on top of the tech. All the way from early detection to high-risk screening to diagnosis to post-diagnosis and oncology treatment, for example. And we are building basically both paths out. And that's why I'm so excited about QuantGene. I think that is a game changer because no one does that right now. Our technology stack spans across the entire course of disease. It's kind of an end-to-end solution from detection or early detection all the way to treatment and hopefully remission. Because once you are in treatment for a cancer, of course, the game doesn't stop, then it starts like the precision medicine game. You want a deep insight into your mutational profile. You want to understand AI-based, what are the best combination treatments based on my unique tumor profile. All of these things are absolutely immature right now if you go to any standard hospital. Like often they don't even sequence you. They don't even know your mutational profile. If they do, they don't know your germline, which is very important. That can also inform treatment. Even if they know all of that, they don't know always what the best treatment combination is because that science is also getting very complex, right? What if you have a target, you have breast cancer, you find one target, a triple negative or something, and then that informs an FDA recommended drug for breast cancer. But what if you also found 2 additional mutations that are known in another cancer, in lung cancer, to block that drug, but it's not approved for breast cancer? Right? Normally it's like, whatever, it's breast cancer, just give it anyway. But on a molecular basis, you know exactly it cannot work. If it doesn't work in lung cancer, it also cannot work in breast cancer because the drug is getting blocked by a protein that is definitely found now to be mutated in breast cancer. So there's just no doubt it's going to fail, but you get this drug anyway. And if you get chemo drugs that are guaranteed to fail, that's not good. But it's just not yet in standard of care because it might have been found 3 years ago and it's not in standard practice yet. But you don't care. You're the patient. You don't care if it's standard practice. You don't want to die and get a chemo drug that will fail.
Right, exactly. Because the patient is interested really only in the final outcome. Exactly.
And so a normal oncologist is vastly outnumbered by the science and complexity, right? They can't do all that sequencing. You can't even read these things up because they become a combinatorial problem. Like there is no specific study. There's one study showing that drug will fail, and the other thing shows it works if you have the other mutation with that drug and the FDA approves it. So how do you even know that in another cancer it's shown to fail? Like that's getting very complicated. And then let's say you read up on it and say, okay, not that drug. Okay, but what then? Like what is the alternative? So that is why we have AI systems in precision oncology that help us to actually determine that. They read 25 million publications every 2 weeks. Good luck doing that as a doctor. And they understand what they mean. They weigh them mathematically and they look at the combination treatments and then give us a ranked list of the best likely match for your full mutational pattern in the tumor. But 99.5% of oncologists have never heard of that because it's new. It became possible basically in December last year. So, that's why you want in the end a precision, companies that are specialized on getting that all in, digesting it and giving you these kinds of insights, especially if you have cancer. But of course, also in early detection, it's important.
You've indicated, and it's clear just listening to you, how excited you are by QuantGene, what the work that you're doing and the potential of this technology and this area of science. And to me, it is fascinating. It takes preventative medicine to an entirely new level. I'm just curious, and I don't really know the answer to this. I'm just wondering what proportion of the audience, perhaps listening to this conversation or similar conversations, are equally excited. And by that I mean, I think there's a certain section of the audience, and by audience I mean populations around the world, who simply don't want to know. There will be people listening to this saying, I'd rather not know to that detail what's actually happening in my body, and I'd rather just get on with my life. Now, clearly there is the potential to tell them a tremendous amount, but I think you're perhaps coming up against human nature with some people.
Well, I think that's an excellent point. I think there's a very simple response to that. There are 2 types of knowledge. One is the old school. I'm saying old school, even though the vast majority of physicians are not there yet. So for them, it's the future. For us, it's the past. Is just germline risk predispositions. So it's like, okay, do I really want to know that I have an 80% chance of getting Alzheimer's before 60? Well, probably not. That's a very big burden because you can't do anything. It's not happening now. and you're basically screwing up a little bit your life through that knowledge because there's no pathway of action. You can prepare yourself for it, but you don't want to live a life where you prepare for, Alzheimer's before 60. I mean, you have much more fun things to do.
Because you're living your life, you're looking at the potential systems, you're looking at the potential symptoms every day. And clearly people will think of memory loss and just stressing yourself, you would think.
Exactly. So that's the first type of genomics knowledge that is scary. And I totally understand why some people don't want to know that. The second type of knowledge is, okay, we can put a screen, an extremely high resolution genomic screen over your body every year to detect any form of tumor at the earliest stage. So we can send you to the hospital and you will be cancer free in 1 week and never deal with it again with that cancer. It's very hard for me to see why you would not want to know that. So, it's basically one is like, if you think in bigger terms, it's like telling a nation, okay, there will be an asteroid and you will all die next year. And you can't do anything. That's not very useful knowledge. Well, maybe it is, but I wouldn't like to know that.
Right.
The other thing is like, no, there's an asteroid coming and we have 3 options on the table, but we only have 1 week to act. That's knowledge where everyone's like, yeah, I want to really know that knowledge because I don't want to be in this first situation. I want to be in the second situation so we can take action and avoid the problem. So that's how we see it. Like at Quantgene, we want to take that whole genomics game to the next level through liquid biopsy, for example, very different from 23andMe and these systems where we are fully action driven, right? We only design products and solutions to keep people safe. Not solutions to just tell people terrible things that are going to happen where you can't do anything about it. That might be sometimes a side effect. That's why you get informed consent and why you can opt out of these kinds of information pieces. But we are really focused on the other side of things. We want to make sure if there's anything going wrong in your body that you want to know this much, much earlier than you would normally know, trace down the problem and remove the problem.
Let me ask you this, Joe. You say you and your company have a mission of extending human lifespan, and with lifespan, of course, comes health span as well, extending it by 10 years within the next 10 years. So if you assume that and acknowledge that the average lifespan, at least in the Western world, is about 80 years old, 79, 80 at the moment. Do you think it's realistic that by 2031 we'll be looking at an average lifespan of about 90?
I think it's absolutely realistic with the right systems in place. And I think it's absolutely realistic to design these systems and make them work. Is it realistic to scale this to the entire population by then? That's clearly not realistic. So there are aspirational things in our mission and there are realistic things in our mission. And my approach here is, well, if we can get to a point where we show statistically that we extended the healthy human lifespan of the Serenity customer base by then, or hopefully 5 years within 5 years, like to show we are on track, that helps us build the firepower to bring it to everyone faster. So I always think as a technologist, it's like a little bit like Tesla, right? Is it realistic that all people have amazing electric cars in 10 years? Of course not. But can you build something that demonstrates in very stark terms to everyone that it's absolutely possible? And the only reason you don't have it is because you didn't buy it yet or someone else didn't make it available. That's what we want to get at. We want to have overwhelming evidence and demonstration that this is technologically possible and in 10 years. And in order to demonstrate that, there's only one way. You need 1 million or 2 million or 5 million customers who all live 10 years longer on average, which is statistically very easy to show if it's true. And then you have something where, Medicare and all the people who are normally resisting too much innovation can't resist it anymore because it's too outrageous. It's like, okay, fine, really, you're not going to pay for this. So that's what I learned. I mean, that is, if you go to all these insurance systems or governments and try to convince them of something smart, you just have no chance, right? It's just not how the system works. They have very different incentives, very different thinking patterns. So you can't just go there. It's like, oh, look, we keep all the patients safe. And they're like, oh, fine, no problem here. So you need to find a much more savvy model. And I think the savvy model is, okay, we build a more perfect system of precision preventative care ourselves. We find people who are willing to pay $200 a month for it. We are building the system out with them, train the system and make it really, really good. And then we start a campaign, a public campaign around that and say, look, guys, here's the evidence. We built a clean new system and we can make the system work. And after 2 years, we show, look, in average, we are already at 1.5 years extension compared to the comparison cohort. In 5 years, maybe you're at 4 years. And in 9 years, maybe you're at 9.5 years. In 10 years, you're at 10 years. And it's like, look what's happening. What are you going to say about that? Like, it's time to bring this to everyone. So that's kind of the strategy here.
And presumably, the younger the better for people to undergo these deep diagnostic tests, because presumably if you're learning things about yourself in your 20s and 30s and repeating the test as you get older, then you're clearly much better placed to extend your health span and your lifespan.
Yeah, absolutely. I think from a tactical medical perspective, of course, 50 plus is the most recommended age, because then it gets kind of more serious in terms of probabilistic, frameworks. You're just more likely to have a problem. But you are absolutely right. If you start this with 35, you will have a much more robust data set, because something we didn't discuss statistically, this is about combining these three different dimensions to get to an actual positive predictive value. But it's also building true personalized precision medicine. So we need your baseline. If I compare mine with yours, it's helpful, but it's not as good as comparing mine with mine last year. So the more you're building up this base, the more you're investing into having a really sound system of statistical evidence for yourself.
And let me ask you from a personal perspective, from everything that you've learned so far in your career, with an eye on your own longevity, is longevity, first of all, something from your own perspective that you think about and what you will be like, your state of health will be like in the decades to come? And is there something especially about the science that you maybe think about every day and apply to yourself with your own lifestyle?
For sure. I mean, that's not I might be on the extreme end of things here. Obviously, I think about this more than a lot. 3 things. Number one, I believe in what we are building at QuantGene. I think that is the first lowest hanging fruit, is to have precision diagnostics on a genomics level and AI driven, because that's the first low hanging fruit, how to extend it actually by 10 years. If you ask me what our plan is after this decade, I think then it goes much more into active life extension, which is more proteomics based, where it's more about actually inventing things you inject and stuff like that to reset your body. That's going to be also very quantitative science. I think we have some very good ideas there, but this is going to take a few years before it becomes more serious. So that's the second dimension. I think there are things how you can bring it from 90 to 100 or 110 that will require a whole different technology stack that goes beyond diagnostics. And then third, for myself, I mean, I have a pretty radical philosophy. I understand that the idea that you can inject something or eat something specific right now that extends your life is not true. I think we will have that in the future, but to design that is not something we can biohack or something. It needs to be a very deliberate, very extensive R&D effort that is pretty clear to me at this point what it needs to be. But it's not going to be easy. It's going to cost a lot of money and be a little complicated. So there is no trick to just eat something and then live longer. So right now what we can do is 2 things. First of all, precision genomics and like early detection, because that gets rid of a whole set of big risks. And second, leverage your natural powers as much as possible. So the unnatural stuff is simply not available right now. So I would forget about that. So it's really about leveraging the natural stuff. And the natural stuff is avoid the 4 big problems, right? Metabolic disease, cancer, cardiovascular, and of course neurodegenerative. And in my opinion, cancer is a special case where it's all about early detection. The other 3 are lifestyle, nutrition, and exercise, all 3 of them, plus a little infectious diseases maybe. And on that side, I mean, I live here in LA. Everyone's about micro dosing, mushrooms, and all kinds of stuff. I'm not the biggest believer in that. I think you should like medium dose chicken breast and broccoli, and you should just eat healthy. And another thing is like this body positivity thing is also horrific for me. Like, people don't even understand what being obese or overweight does to your body. It's just obscene. It's like a perversion of what, I don't know what went wrong with people, but to tell people it's fine to be obese, they're just crazy. I mean, it's like telling people it's fine to jump off a bridge. It's like, well, it depends what fine is, but it's not healthy. And, I think to be absolutely on top of your game and take this extremely seriously is where the life extension is. You need to be happy, socially balanced with friends and family. You need to have very, very good nutrition, which means just very normal, natural nutrition, whole foods, like the whole thing. Everyone knows the trick, but you have to go with it. And exercise, not crazy, not like marathons. You can do that if you want, but it's more about a balanced exercise. And I think, don't go crazy and radical without it. You should be radical about balancing these things out. You should have radical balance and not accept being in a bad mood, bad shape, bad energy. So we need to all become a little Californian about it without the drugs. And I take this extremely seriously. I'm very hypochondriac when it comes to my nutrition and basic well-being. Not that I'm great at it. I'm very obsessed with it. I'm sometimes a little stressed because we're running a pretty complicated thing here. But I know every day I'm stressed or eat wrong, it's going to, kill me a little sooner. I have no illusions about that. And I think that's very important. We have to understand that.
I think it's fascinating. And just a closing thought, I'd be intrigued about your view on this. What do you think in terms of aging and a maximum lifespan, what do you think ultimately the human body is capable of?
I think we can relatively easily push it over 90 with just being very healthy, being on top of our game, and having all kinds of advanced diagnostics and early detection. That's where this brings us to. If you want to push it over 100, I think you're running against a very natural problem that is around 100, 110, where you just die. To break through that barrier it's 100% possible. There's no doubt about that. But in order to do that, there you need like severe interventions. And that means, it's out of question. In the end, you need some magic elixir that you inject in people. That will do the job. The big question is, what is that? I think it is about resetting there is also no doubt that death is artificially designed because you have organisms that live forever. It's no problem to live forever in theory. So your body is kind of designed to have a certain lifespan. It's very clear why. Because evolutionary, it's a total disaster if you don't die. So you need the turnover. You need to get rid of the old genes and give the mutations a chance. Otherwise, you become non-adaptive and just die, of course, as a species. But of course, humanity moves into this whole new thing we are doing. Like this whole game is done now. There's a new paradigm. Of course, humanity can adopt genetically easily very soon, like synthetically. If we think that's a good idea or not, plays no role because it's definitely going to happen. Then we are pushing into that new era where you can also talk about much more extensive life extension. And I think it's all about understanding this aging clock, which I think we sufficiently to some extent understand. It's a systemic clock. It's not one thing. It's the entire system situation, which is the entirety of all your proteins and all your fats and lipids that are in your body, the exact, quantities and constellations, and that informs a lot of things. And if we learn how to reset that clock, which will be very complicated, but possible, then it will work. And we already have, the mice experience parabiosis, sharing blood streams, and suddenly things happen because that's exactly what that does. If I inject you with young blood or replace your entire blood with young blood, you will feel amazing. There is just no doubt about it. And you will look much younger. Everything will be much younger. Of course, that's not really doable. But we tested with mice. So solving that problem will not automatically lead to eternal life, right? You still have degradation and stuff, but that will give you another 10, 20 years or something, and then you can go from there.
Joe, this has been a fascinating conversation. You're doing some really good work. Thank you very much indeed.
Thanks a lot, Peter. I appreciate it.
And if you'd like to delve a little deeper, and there is much to dive into, I'll put a link to QuantGene in the show notes of this episode at the Live Long and Master Aging website. That's lamapodcast.com, LLAMA podcast.com. In social media, you'll find us at Lama Podcast. You can contact me at Peter Bowes. The Lama Podcast is a HealthSpan media production. We're available on all of the major podcasting platforms, including Audible at audible.com. You might listen to books there. You can also download this podcast free of charge. Wherever you'll find us, take care. And thanks so much for listening. Health optimization is what this podcast is all about, and that means taking care of our mitochondria, the energy centres of our cells. Physical strength, avoiding frailty is key, and that's why the science behind urolithin A and the work of Timeline Nutrition is so interesting. You can find out more and get a discount code at our website and in the show notes for this episode.